dear students, today we are going to discussing about work energy theorem. So what is work energy theorem? Before we going to work energy theorem, we have already learned in previous lecture what is work. So I pinned in the comment section of video work. So first of all, what is work? Work is force into displacement into cos theta. So what is theta over there? What is theta? Angle. Theta is the angle between force and displacement. Theta is the angle between force and displacement. Now, what is energy? Which type of energy here we are going to discuss? Yes, of course, kinetic energy. What? Kinetic energy. What? Kinetic energy. Kinetic energy? Yes, what is the formula of kinetic energy? Is equal to half mv square. Yes, you already know this is, you have already learned. Okay, so what? They are related to work energy theorem. What? Work and kinetic energy are related? Yes, they are related. Okay, so the next is work done. What is work energy theorem? So let's work done. Work done is equal to change in kinetic energy. Is it related? Change in kinetic energy. Change in kinetic energy is work energy theorem. Yes, work done is equal to change in kinetic energy. So what is the? This is the work energy theorem. Suppose there is a block. Suppose there is a block moving slowly, but when I applied a force, keeping applying a force, it's moved fastly. What happened to this block? What? I have done the work. Yes, I have done the work. Force in this direction and displacement is also in this direction. So work is still done. But where is my kinetic energy gone? Where is my energy gone? Yes, energy is using in movement, increasing their velocity. So what? When I applied a force on block will move fastly. Okay. So what I see there, we see that in the block system, my work is acting as kinetic energy, change into kinetic energy. So what is the work done? Work done is equal to change in kinetic energy. What is the word change in kinetic energy means? Means something big, something small. The difference between something big and something small is change in something. So change in kinetic energy is kinetic energy final minus kinetic energy initial. Okay, this is change in kinetic energy final minus kinetic energy initial. Let us an example as a numerical. Let's take an example as a numerical. So I am going to rub this. Okay, bachcho? So what is the work done? Work done is change in kinetic energy. Work done is change in kinetic energy. Kinetic energy final minus kinetic energy initial. I repeat this one. So I am taking a block of mass 5 kg, moving slowly, initially in moving position. U is initial velocity, initial speed. What? Let's take 10 meters per second. Okay. After that, I am going to apply the force in this direction. I apply the force. This block started moving, already moving before, but when I applied, its movement is keep going. When I applied force, after I am pushing, block will over there and displace such distance. displacement. Displacement कर गया. Displacement is from there to here. Okay, बच्चों? Okay. So what is changing? Because I applied the force in it. So what? Movement, kinetic energy increases. So what is velocity get increases? What is velocity? Suppose velocity is over there 20 meters per second. Final velocity is there. This is the block, same block. So what? I applied a force on block. Its mass changes? No. So what is the mass here? Overall mass is 5 kg. Remain same until mass remains same there. So what is the work done here? Work we can find by what? Force into displacement. But there is force, but not given the actual value of force, not given the actual value of displacement. How can we calculate work done? How can we calculate work done? How can we calculate work done? Another example is work done of change in kinetic energy. Change in kinetic energy. We also know this is the work done, change in kinetic energy. What does it mean? Change in kinetic energy. That means kinetic energy final minus kinetic energy initial. Okay, bachcho? This is work done. This is work done. So what is the formula of kinetic energy, bachcho? You have already learned kinetic energy is equal to half mv square. So what is over there? Final kinetic energy is that one. Final kinetic energy is that one. So half mass is 5 into v square is 20 whole square of whole square. Okay, bachcho? 400 into 5, 400 into 5, 1000. What is it? 1000 minus kinetic energy initial. What is initial over there? Half into 5 of our 10 square. So what is that? That is 100. 100 into 5, 500 of 250. What is left there? 750 joules. You can calculate it easily by this formula. We are shocking to get the work done without displacement, without knowing the actual value of force. And this is shockingly what that? This is the work energy theorem. This is the work energy theorem. We have find the work done without knowing displacement and without knowing force. This is shockingly. And that is the value of work energy theorem. Work energy theorem. So what? We are going to take another example. So what? Yes, work done. What is work energy theorem? Work done is change in kinetic energy. Let us we explain you by something different way. I am going to explain you by different way. Let us take an example. Cricket field. Ball is coming from there and we are catching the ball. That means I am stopping the ball by just applying force like this. By just applying force like this, we stop the ball. I am trying to stop the ball, but what? The ball hits my hand backward and displaced there. So I applied the force there and ball displaced there. What is the angle between them? What is the angle between them? Force is there. Force is in this direction. I applied and ball displaced in this direction. So what is there? F S cos theta. What is here cos theta? Theta is the angle between force and displacement. What is theta here? 180 degree. So 180 degree, what get? Negative value. Negative value. Cos 180 is -1. So overall the work done is negative there. So what we have looked there? We have looked there, work done is positive as well as negative. Work done is positive as well as negative. Let's this example through work energy theorem. Work energy theorem, what said? Work energy theorem, what? Change in kinetic energy. Yes, bachcho. Yes, bachcho. Change in kinetic energy. Change in kinetic energy means kinetic energy final minus kinetic energy initial. Is there? What will happen there? Work done. This work by formula. This work is by formula. Work done by work energy theorem. Work done by work energy theorem is what? Change in kinetic energy. So what? Kinetic energy final minus kinetic energy initial. So what here? Ball is coming in my hand and finally stopped. So final velocity of ball is 0. So final kinetic energy is 0 and initial kinetic energy is something, maybe their velocity. That's why coming the ball in my hand towards me. So negative value. Oh, what do we get? Both are giving the same result. Yes, this is the work energy theorem. Here works get negative also. Here also get negative. Okay. So work energy theorem proves that. How even sorry बच्चों. Yes, work energy theorem works even when we kinetic energy decrease. Ball is coming in my hand. What we do? Decrease the velocity. Or by pushing the block, increase. That means whatever we get, the work done positive or negative. Change in kinetic energy. Whatever we do work, there is change in kinetic energy. Either we slow the something, we fast the something by pushing. Okay, and there is the work done. And there we will use work energy theorem, and also we can use work as Fs cos theta, force into displacement into cos theta, which is we have already learned. Now you are going to ask me, prove this one how? Why we believe? You will ask. Let's go to the proof. Okay, I will take another example. This is my sketch falling down. What? Why this? I did any work in this pan. Why this fall down? Due to gravity. Gravity pull it downward. That means gravity is doing work. Gravity is doing like work is, which results in change in kinetic energy. There is a stop, and here is fast, and here is finally stop, and so there is the work done. Okay. Now I am taking going to prove work energy theorem by what means. What is work done? We now formula of work done. What is change in kinetic energy? So this is going to be here. This is going to be shift in right side. So right side is what? Change in kinetic energy. Change in kinetic energy is equal to what? Kinetic energy final minus kinetic energy initial. Okay, बच्चों? Okay, dear students. What we know about kinetic energy final? That means half m v square minus half m u square. Initial is u velocity, final is v velocity. What is come there? Common term is we can take common as m. So we take m is as common. What is left over there? V square minus u square upon 2. Yes, we can multiply anything with denominator and numerator. We can multiply something there and there also with numerator and denominator. So what can I multiply denominator with? Denominator with something term and numerator with also the same term. Yes, we can. For example, we can multiply 5 over numerator there. We can multiply 5 denominator. So in a similar way, we can do this. So what? I am going to multiply a. I multiply this term a. So we multiply also over there a. Overall, this out remains the same. What is this? You know what? You know, dear student, what? Ma is force. Force. We are going to use identity theory of motion. What is that? V square is equal to u square plus 2as. You already know this very well in 9th standard. So what? V square, this come here, minus u square is equal to 2as. What is there? S upon v square minus u square 2a. What is this? What is this? What is this? This is and this is are same. So what is over there? This is displacement. So into displacement. S. And what is that? Displacement. So what is work done? Work done is Fs. Work done is Fs. So this is proved and proved. Already bachcho, we are doing a lot of hard work and your Vidyadhara member also doing hard works. Thanks for watching my videos. Support us. Support family of Vidyadhara.